The purpose of this production is to revise esterification. And to start with, we need to be able to identify the main functional groups. For example, the first one, the functional group or special part of the molecule, makes that an alkanol. This functional group or special part of the molecule makes it an alkanoic acid. C double bond OH acid. And the last one, this functional group, C double bond OO, in the middle of a carbon chain of any length either side, is the ester. The process of esterification involves an alkanoic acid reacting with an alkanol to give an ester plus water. Notice it's an equilibrium reaction. It doesn't go to completion. There is always some alkanoic acid and alkanol left at the end, and it requires an acid catalyst, concentrated sulfuric acid. Now for the experimental setup. The procedure is referred to as refluxing, and it involves having a condenser in an upright position with the water going in the bottom and out the top, providing a cooled surface on which the volatile ester, once it's formed, does not escape into the atmosphere but goes back down as a liquid into the reaction vessel. The reaction vessel here, a pear-shaped flask, is where you would put your OL, your oic acid, and your acid catalyst, which is concentrated sulfuric acid. For the equation, finishing this example in words, ethanoic acid plus methanol. The surname of the ester comes from the acid, so an ethanoic acid makes an ethanoate. The specific ethanoate made in this case will be methyl. Methyl ethanoate is the ester plus the other product, which is water. A word equation never suffices. A balanced symbol one is always required, and you need to have a full structural formula provided for each of the reactants and products. So to draw ethanoic acid, eth tells you that you have two carbons. To be an acid, you need to have a C double bond O OH on an N carbon, and come back and make sure that each carbon has 4 bonds by putting in hydrogens where necessary. For methanol, meth means it's 1 carbon. To be an ol, you need the OH group, and again come back and make sure each carbon has 4 bonds. Still an equilibrium process requiring an acid. Now to draw the ester, you draw the acid, but you leave off the acidic proton. So redrawing the acid to look like it did before, but leaving off the acidic proton, and in its place you are drawing the carbon chain of the alcohol. Here just a 1 carbon chain. So that means that we have put the larger part of this and joined it onto the carbon chain here. That means that what's left is the part that forms the water. So the hydrogen here and the OH here joins together, the two little fractions join together to make the other product, which is the water molecule.